All right, the next part of your notes has to do with taking functions and finding their inverses. And remember, we had a property called the inverse property, where things cancel out or where you do opposites or reciprocals. So inverse functions are similar to that. They are the opposite of one another. And we're going to talk about what happens when you put them together, just like our multiplicative inverses or our additive inverses or whatever. So here are the 4 ways that we can represent and work with inverses. Okay, first thing is that if this is the function, the inverse is written with a little -1 in its top right corner, okay? So we know that that means function and that means inverse function, okay? It says inverse functions are symmetric around this dotted line, y equals x, okay? So for example, if we had like a curve going this way, okay, we would flip it, and that would be its inverse function. So we would flip it like that way, okay? Those would be inverse functions. It is the mirror image, okay? So then, when it comes to ordered pairs, this is probably the easiest part. If we've got x and y like normal, the inverse function is when we switch them. So instead of 3, 2, we switch them and we just have 2, 3. Okay? So it is when we reverse them. Y becomes x and x becomes y. Alright, so in inverse equation, it says we rewrite the equation by switching x and y. Then we solve for y to get the inverse equation. Last year we found that that was kind of a long process. So the other thing that we did, kind of the shortcut that we did, was that we actually applied the opposite operations. Okay, and I'll show you what that means. Okay, but like if the function is adding, then the inverse function is going to subtract. If the function is multiplying, then the inverse function is going to divide. So we can also think of it as opposite operations, and that will get us that inverse equation, okay? And then composition of inverse, well, remember composition means you take one function and you put it into another. And when we do that with inverse functions, we get x every single time. So when I put, it says if f of x and g of x are inverses, then it always equals x. So if I put the g function into the f function, it comes out as x. And if I put the f function into the g function, we also get x, okay? So whenever, that's how we know if functions are inverse, is that when I put one into the other, I get x out. Everything cancels out except for x. Or and then if I reverse it, I still get x out, okay? So that is just kind of the different ways we could see inverse functions. All right, so here is our first example, okay? I can tell that this table is a little bit hard to see, so I'll rewrite it. All right, so the first thing, it says, given f of x, find the following. So we're first going to, okay, so the first thing we're going to do is find our points using a table. So if the function is, let me erase this too. All right. If the function is x plus 2, so I'm going to make a new table here just because it's hard to see it over there. All right, if I put in a 0, and I put a 0 right there, I'll get 2. If I put in a 1 right there, I'll get 3. And if I put in a 2 right there, I'll get 4. Okay, so you can put those on your table right here if you can see it. So the original function, it says sketch the original graph. So here's the original function. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. All right, so 0, 2, 1, 3, and 2, 4. So, and it says to use a dotted line. So we are just going to make a dotted line right there. Okay. Now I'm actually going to skip down here because these relate really closely to each other. and then we'll talk about the equation. I'm just going to write it the same way, rather than using the table there. I'm just going to put it there instead. Okay, and the thing is, and it said it about ordered pairs, you just switch them. So if this was 0, 2, then the inverse is just 2, 0. And if this is 1, 3, the inverse is just 3, 1. And if this is 2, 4, the inverse is 4, 2. So you literally just switch x and y, and then you're going to see that it is going to reflect, like I showed you in that first, on the upper part of the page. So 2, 0 is right here. 3, 1 is right here. And 4, 2 is right there. And it says to do a solid line. I am fortunate enough to have colors, so you can kind of see it on my page. But if you notice that they are a reflection, this was the original, and if you were to flip it, that would be its inverse. That is its reflection, okay? And so that's how we can see that those are inverse functions. And that actually, I heard, was some questions that you might see, is that, recognizing these graphs, okay, that it flips over that dotted line. So then it says find the inverse equation. Well, to find the inverse equation, all right, to find the inverse equation, the long way is to take y equals x plus 2, so I just rewrote it with a y, switch these two, so that means x equals y plus 2, so all we did was we switched these two, and then you resolve for y. So if you've got x equals y plus 2, in order to get y by itself, you would subtract 2 over here, and you would get y equals x minus 2. So the inverse is x minus 2. Well, one pattern that the classes, I'm going to write that just a little bit bigger. One pattern that my classes last year and I discovered was that it's really just the opposite of whatever we're given. So since the original function is plus 2, the inverse function is minus 2. And so there's a direct relationship between what you start with, because you have to undo it in order to do the inverse anyway. So you can write it down, switch them, and solve, like I did right here. Or you can just think, okay, the opposite. Opposite, if I'm adding, then the inverse subtracts. If I'm multiplying, then the inverse divides. If that's an easier way to think of it, okay? So these are the three parts that have to do with the points, that have to do with the graph, and that have to do with the equation, okay? So this equation, let me write it in blue, is f of x equals, let me erase those, x plus 2. And then this is our inverse function that says f of negative, the inverse of f of x is x minus 2. So if you were to put those two in your calculator, you would get those two lines, and they reflect across that dotted line, okay? So then I want to show how they'll cancel out, and you will just get an x. Every time you put you put the inverse into the original, you will get x, okay? So let me scroll down to D. And show you this last part. Okay, it's not something that I really hounded too hard on last year, but I do think it shows up on the SOL, so I want to make sure that we go through and you see the relationship. Okay, so we know that the original function, here I'll put it over here just so that I can refer to it, f of x is x plus 2. And the inverse is x minus 2. Okay? So what we're going to do is we're going to put one inside of the other. Alright, so when I do that, I'm going to start with the f function. So that's x plus 2. And then I'm going to put the inverse inside of that. So the inverse is x minus 2. So it's referring back to those, like putting functions inside of functions, those composite functions. So that is just Why do I keep losing my markers? Okay. All right, so that is just x minus 2 plus 2. And again, I mentioned everything should cancel except for x. So you should always get that x out. Always, always, always. Okay? So then we do it the same. We have to reverse it because it has to work in both scenarios. So I'm going to start with the inverse function, which is x minus 2. And I'm going to put in the original function, which is x plus 2. Again, there's no distributing or anything, so really that just means x plus 2 minus 2. Positive 2 and negative 2 cancel. And there I have my x right there. Okay, so this is just an example of how when you do a composition of the inverse and the original, both directions, everything cancels except for x. And that is going to happen no matter what the functions are. As long as your original and your inverse are accurate, then they will always work out to just x. Everything else goes away. Okay, so we'll probably practice in class on those next parts, okay?